Page 41, apparently. Is that right? No, that's not right. No, that's not right. I don't actually have that one done, so I actually have to do it. 108 is 36 times 3, and 240 is 16 times 15. Pen's dead. So that is 12 root 15 over 6 root 3, which is 2 root 5. And then D is, that's the wrong one, 4 root 3. And you are all checking your own work, of course, not talking. And you will say, Mr. Myers, stop, when you get a different answer than me. Everybody okay with those ones? G. So what are you going to do with it to get rid of the radical in the bottom? Root 6 over root 6, which gets you 2 root 6 over 5 times 6, which is 30, right? 2 and 30. 2/30 is 1/15, right? Right? You don't need your calculator to tell me 2/30 is 1/15. Okay, so we don't write the 1, so it's root 6. Did it just disappear? Of course it did. I'm trying to go wireless today. Connection with the projector has been disconnected. So there you go. Can you explain K? Yes, I can. So, in K, you could simplify first, or you could just do root 88. So it's going to be negative 2 root 88 over 88, right? Okay. 88 simplifies to what? It's 4 times 2 times 11, right? Right? So out comes a 2, right? So I get negative 4 root, what did I leave under there? 2 and 11, 22 over 88, right? Right? Now what? How many times does 4 go into 88? 22 times. So it's negative root 22 over 22. I had what? Oh, I was missing a 2? Well, that's weird. And down to A here. Now, A here is weird because when you do the work, you're going to end up with that, right? Which you could simplify once more, technically, to root 14 over 2 minus 1. But I'm happy with either one. And then this one is 1/2 minus root 6 over 3. Everybody good there? Okay. And these two, it's just same thing. Except when you multiply by root 5 over root 5, you get big numbers here, right? So what should you do first? Simplify, because that's 9 times 2, and that's 4 times 6. So that's 30 root 2 minus 10 root 6, all over root 5. And then you rationalize your denominator to get 30 root 10 minus 10 root 30 over 5. Then, because 10 and 30 are stuck, you just deal with all these. 6 root 10 minus 2 root 30. Same thing over here. Simplify first when your computer starts working. Nine times 2 and 121 times 2. So it's 45 root 2 minus 33 root 2 over negative 3 root 8, which is 12 root 2 over negative 3 root 8, which I would simplify again to negative 4 root 2 over root 8. Then I would rationalize to get negative 4 root 16 over 8, which is negative 16 over 8, which is negative 2 when your computer works again. Any questions about the simple rationalization? Going once. Going twice. Going thrice. Everyone can rationalize a monomial denominator. Can I what, huh? Be at the top? In the top right? Yep. Would have been nice if you'd said that, 15 minutes ago when I was doing B, but that's okay. Simplify if you can. That's 4 times 5. So it's 18 root 5 minus 3 root 10 over 3 root 2. We multiply by root 2 over root 2. Our computer stops working, so we wait a while. You know what never stops working? Pencil and paper. You never have a non-responding there. So then, of course, Priyanka, you get 18 root 10 minus 3 root 20 over 3 times 2 is 6. Then you simplify, or I would then simplify this guy because he's 5 times 4. So that becomes negative, or not negative, dummy, 18 root 10. Out comes a 2 minus 6 root 5 over 6. Cancel, cancel. That becomes 3. 3 root 10 minus root 5. And the 6 is gone. Oakley dokley. Oakley dokley. So, on the last once, twice, thrice, I caught somebody. I'm going to ask again so I don't get accused of going too fast. Can everybody rationalize a monomial denominator? Going once. Going twice. Going thrice. Excellent. Turn your page over because now we get to the good stuff. Look at number 1, A. What bothers you about that? It's got a binomial denominator is no problem. We know how to deal with binomial denominators, or we know how to deal with binomials, right? We've had binomial denominators in many, many, many things we've done. So the fact that it's a binomial by itself doesn't bother us. But there's something about that binomial that does bother us. Radicals in the denominator. Is that allowed? No. Now we know how to get rid of a single radical in the denominator, yes? We rationalize by multiplying by itself, right? So we know we got to multiply by root 15, yeah? But we also have a root 10. So we know we got to deal with the root 10, right? Right? So, before we go on, I need to remind you guys of something that you should have noticed 2 days ago when we were doing multiplying radicals. So I'm going to do a quick review. What is, it's too big a number. What is x plus 7 times x plus 7? What do I get? X squared 14x plus 49, right? And what if I do x minus 7 and x minus 7? Then I get x squared minus 14x plus 49, right? What happens if I do x plus 7 and x minus 7 then?
X squared minus 49.
No. Oh, yes. X squared minus 49. What happened in the third case? Negative 7x and positive 7x disappeared, yes? The middle term dropped out, right? And you will notice the middle term dropped out because we changed the sign, right? This is what we call a conjugate because we changed the sign. Now, back in grade 10, when you were learning how to factor a difference of squares, you learned this. But your grade 10 teacher might not have called it the conjugate. Any of you that were in my class did. Okay? So a conjugate is simply the same polynomial, which in this case is a binomial, with the opposite operation. Okay? Everybody got that? That's what a conjugate is. Please, please, please get your highlighter out and learn that word. Put a cloud around it, put a star around it, underline it. I don't care. But know that word. Because the conjugate allows us, you will notice, to get rid of this middle term. Right? So you guys would say, if we were going on what you already know, some of you are probably already thinking, well, why don't I multiply root 15 minus root 10 over root 15 minus root 10? Because then that's times 15, that's times 10, right? And they would disappear. But because they're subtraction, does the middle term disappear? No. If I FOIL that out, root 15 times 15 is what? 15. Awesome. Root 15 times negative root 10 is negative root 150, isn't it? And don't we want to get rid of radicals? So we can't multiply by what we actually have. But if I change it to the conjugate, what happens? What's root 15 times root 15? 15. The middle terms are going to drop out, which we already know from binomial multiplication, right? So root 15 times positive root 10, root 15 times negative root 10 is going to disappear. And then we're going to get, what's root 10 times root 10? 10, but it's got to be negative 10. Any radicals on the bottom? Is my denominator rationalized? Yes. But am I done? Of course not, because I got to deal with the top. Root 7 times root 15 is root 105. Plus root 7 times 10 is root 70. And then, of course, I simplify anywhere I can. 105 doesn't simplify. Root 70 doesn't simplify. But I'm over 5. Does everybody see how it works? Does everybody, more importantly than see how it works, because all it is FOIL, do you see why it works? You already knew all this stuff from the 10th grade. Everybody cool? Okay. Let's look at the next one, which looks slightly different, and tell me what you think you should do. Don't write it down yet. Let's just make sure. What bothers us about B? He waited patiently. He continued to wait patiently. He still waited, still patiently. There's radicals in the denominator, but they're different, aren't they? Because they're mixed. When we had a monomial mixed radical, did we have to care about the coefficient? No, we didn't. What do you think happens here? Let's see what happens if we don't care. So we're going to multiply by root 3 minus root 2, right? Agreed? Okay. Well, 2 root 3 times root 3 is 6, right? Because that's 2 times 3. 2 root 3 times root 2 is negative 2 root 6. And what's root 2 times root 3? Positive root 6. Is that radical going to drop out now, Max? No. So when we are doing mixed radicals in binomials, I am not allowed to forget about the coefficient like we did in binomials. Does everybody see why? If you didn't see why, I'll go undo, 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 and now you should see why. Did this middle term drop out? Is negative 2 plus 1 0? He waited patiently for that complicated answer. No, of course not. So you have to remember to keep any coefficients when you are using binomials. Then, does anything change? He waited patiently. Max, you should just take over because I'm going to be doing a lot of patient waiting today, I think. It's pretty complicated, right? So, well, I guess nobody wants to talk, so I'm just going to go ahead and write. Is there anybody that can't follow it?
What is 5?
6 root 6 minus 1 root 6. Is there anybody that can't follow it? Okay. What's the one thing you got to remember that is different from monomial denominators? You can't what? Right. You cannot forget the coefficients. When dealing with binomials. So, what should I do with C? I would simplify first. Why? That 12 can be simplified, right? And we saw yesterday that when we simplify first, we might end up being able to fix up the base, right? Or fix up the denominator. So let's simplify this. The top doesn't simplify. But the bottom, that's 4 times 3, isn't it? What's the root of 4? So what comes out? So I have 6 root 3 minus 4 root 3. Now, it becomes a lot easier, doesn't it? Because what can I do right there? I can subtract. I don't have a binomial denominator, do I, Priyanka? It looks like I do, and you want to multiply by the conjugate, but if you simplify, you don't have to. Because what you really have there is 2 root 2 over 2 root 3, right? What do you do with the 2's? Pardon? They cancel. So I've got root 2 over root 3. Is that allowed? Why not? Radical in the denominator. So what do I do to get rid of it? Now it's a monomial, so I just do root 3 times root 3, and I end up with root 6 over 3. Now the problem with this is at least a third of you don't know, even though we've talked about it a million times, don't know that that is where you stop. Because you can't put radicals with integers. But a bunch of you are going to go a step further than this. You're going to tell me the answer is root 2. A bunch of you are. That's why we practice a million times, to remind you not to do that. Everybody cool? All right. Now this is, while it is simple, because it is, isn't it? It's the same thing we've been doing forever, but it's very complex in that you have a lot of moving parts in every question, right? But please notice how much simplifying can help. Because this is really ugly if I had done this. And had to FOIL that. That would have been gross, right? Sometimes you have to. But if you can get away from it, make sure you do. So let's look at this guy. What's different about this guy? Pardon? There's an X in there. Now we've already learned, does X change the way we do things? No. So what do you think I should multiply by here to clean this up? Pardon me? Root 4x plus minus 1. Now, Sukpal, I assume that you were simplifying that to 2 root x, right? That's okay to do. There's nothing wrong with that. The only problem with that, in my mind, is that brings a coefficient to the party that you might forget later. Do you understand what I'm saying? I know I always say simplify first, but this is a pretty simple one already. You know what I mean? And if we bring that coefficient to the party, I would be a little worried that you might forget about it later. Which is once again why I remind you all, look at the question and decide on a course of action before you start it. Do you know what I mean? Don't just go dive in head first. Because if you dive in head first, you might get what happened last time and get something really complicated when it wasn't. Okay? So I would leave this one. I know that that seems weird, but I'm just saying I would leave it. But if you want to do 2 root x, you'll still get the right answer. Okay? So what's the top? Root 4x minus 1. And then I just multiply. What's root 4x times root 4x? The root of 16x squared, right? Which would be 4x. So the denominator is 4x minus 1 when my computer wakes up. And what's the top? Six root 4x minus what? 6. Everybody cool? If you get to there, I'm this happy. Because you could do more with that, right? What could you do there? What do you notice there and there in green? 6 and 6. So a 6 can come out, right? Root 4x minus 1 over 4x minus 1. If you get to there, I'm this happy. If you do what Soupball says and you get to here, I'm this happy. Okay? So your level of how far you go with this depends. Everybody cool? What's different about E than D? The 1 is different. How? It's part of the square, part of the radical, isn't it? So is that a monomial or a binomial? It's a monomial now, isn't it? So would I multiply by the conjugate or by the regular? By the regular. So this one is root 4x plus 1 over root 4x plus 1. No conjugate. So the top is 6 root 4x plus 1 over 4x plus 1. Can I simplify that any more? Can I simplify that more? Where? Can I pull something out of there? What would come out? The 2. Okay, what else? Do you think? I'm going to leave that alone. The question for you guys is, what can you do with 4x plus 1? That's a little piece of bonus work for you. Now let's look at f, because f is freaky deaky. What's weird about that? Because f has some things we like and some things that are weird. What's there that we've seen? I do love first block.
The entire fraction.
Perhaps on Mondays and Wednesdays I should do like addition for the first half of the class. Then maybe we'd be okay.
I just said
What'd you say?
the entire fraction is radical.
The entire fraction's radical. Cool. So this term right here is a problem, yes? Can it be rewritten in a different way? How?
Just split it into
Split it in two.
two radicals.
Two radicals. Okay. So what would that be, Yoon?
So root 4y over root 12
Okay. And where would that 6 live?
outside of it.
Is that cool? Okay, what would you do with that? There's nothing wrong with that. What would you do with it now? Simplify? Okay. So how would you simplify up top? That would be 12 root y. Okay. Over what? 2 root 3. Cool. Okay, then what? Would you? What's 12 divided by 2? 6. So isn't that 6 root y over root 3? Now what would you do, Priyanka? Multiply by root 3 over root 3 to get what? Six root 3y over 3, then what? Divide the 6 and the 3 to get what? Am I done? Okay. Whew. That wasn't difficult. So you guys need to practice this, apparently, because nobody could say even one next step. Let's go with... Let's go with the rest of 43 there. And all of 44. Oh, heck. Let's go up to 46. Where's my pink book? What the hell? Oh. No, that's not my pink book. That's my Fireball Fuchsia book. No, that's Outrageous Orchid. Where is Fireball Fuchsia? That's frustrating.
Staff in suits, effective out of your pension. In the next few minutes, we will practice our first of many emergency preparedness drills. Over the next year, there will be an earthquake, lockdown, and fire drill to ensure that in the event of a real emergency, we are all very well prepared. It is through practice that we will achieve mastery. Teachers, please lead your class out the proper exit. When the alarm goes, assign a student to close the door after everyone is out of the class. Please enter the building through the same door you exited. Any unnecessary comments will not be tolerated. Students in undesignated areas, please report to the middle of the turf field. School will resume when we hear 3 bells. Teachers, please review your fire bell procedures if you have not at this time. And please wait for the bell to go.
Work till the bell goes. We go down these stairs, out these doors, over to the field. I will be locking the door, so you needn't worry about leaving your stuff. Okay? Okay. Let's go, cabbages. Of course you are. Sure. Now, of course, ladies and gentlemen, I recognize your test was interrupted. You have 40 minutes left to complete it. I lie, 38 minutes left to complete it, which is enough time to do it considering the first 4 questions you've already done before. If you do not finish, of course, I will be forced to give you some time tomorrow, and I will be forced to figure out how I am going to count this. You have the option to stay in a little bit at lunch if you wish. You don't want it to spill over to tomorrow, that's fine. But you will get about 15 minutes tomorrow with which to finish this should you need it. Which is kind of nice of me because it allows you to go home and cheat and look over all your stuff, and that's okay because you lost 20 minutes of class right now. That's my payback to you for that. Okay? So work on it, and then whatever you want to do at lunch is up to you. Okay? Carry on. I'll be right here minding my own business.